Hey guys, here is our 9-2, it's actually 9-2 slope fields video for notes. I'm sorry it's not a typical video, but I do not have that set up at home, so we're going to manage with what we manage. We've already talked about slope fields, so a lot of what's on this front page you've already done, and we're not going to do every example, but this table is in case you want to write the slope values down before you graph them. I like to go straight to graphing. On this particular one, our slope is y. So, if the y value is 3, our slope is 3. Here our slope is 2 because the y is 2. 1, 0, -1, -2, -3. So that's what our slope looks like. Now, this next part is the new part to you. It says find the solution, and sometimes you'll see the word particular solution in there. So when you see that, it's your hint going through 1, 1. Well, what that means is separation of variables. So if dy dx equals y, then dy would equal y dx. dy times 1 over y, and I'm going to put the 1 over y out front. So 1 over y dy will equal dx. Integrate both sides, so we get ln of y equals x plus c. Solve it for y will equal e to the x plus c. What this really means is e to the x times e to the c, or c e to the x, and now I can go about finding out what c is using 1, 1. So at this point, if 1 equals c e to the first, then c equals 1 over e, and my answer is y equals 1 over e times e to the x for A. Then for B, all you have to do is take the work you've already done. So go to this point and plug your point in. So 0 equals c e to the -2. That means c is 0. Dividing 0 by e to the -2 is 0. So our equation for this one would be y equals 0. And y equals 1 over e times e to the x. Let's jump down to number 3, just because I'm not going to do everything on here. Negative x over y. Each point you'll have to think about it a little more. When y is 0, we know these will be undefined because you can't divide by 0. And then 1, 1 would be -1. 2, 1 would be -2, 3, 1 would be -3. Zero, 1 would be 0. All of these would be 0 because they would be -0 divided by, this one would still be undefined. It'd be 0 divided by 0. 1, 2 would be -1/2. 2, 3 would be -2/3. -1, 2, 2 would be -2. This would be +1. These would be -1. These would be +1 because x and y are the same at those places. Think through each of these points. Ends up looking kind of like a circle. Now for our particular solution, I'm going to slide this up a little. We get negative x over y. So we get y dy equals negative x dx. We need to integrate both sides. So 1/2 y squared equals negative 1/2 x squared plus c. Always add your plus c to the x. Doesn't really matter which side, but add it to one side, and it's easier if you add it to the x side because our goal will be to solve for y. Multiply by 2, so y squared will equal negative x squared plus still c. A constant times 2 is still a constant. So y equals the square root of negative x squared plus c. So for a, 1 will equal negative 1 squared plus c, which means c is 2, and y equals negative x squared plus 2 in the radical. That's for a. For b, we get 0 equals negative 2 squared plus c, so 0 equals negative 4 plus c, which means c is equal to 4. Negative x squared plus 4. I am not going to do number 2. Here is what the graph looks like for number 2. And here is the algebra. If you want to pause and jot that down, you can. We get an answer for A, but for B, there is no solution. That happens once in a while if the original curve doesn't go through the point that is provided, so it's possible. And D, number 4, I'll give to you for bonus. If you can send me a picture of your correct work for this, let me know. Now, I will tell you, I've been teaching calc for 10 years and we haven't come up with it yet, but that doesn't mean I wouldn't put it past a few of you to be able to figure it out. So what better time than quarantine to have free time to try and figure out a calculus bonus? So if you're up for it, go for it. On the back of these notes, then, is an AP question. And I don't know for sure what your AP questions are going to look like. I assume they will be more like short answer and less like extended response, only because extended response one problem doesn't cover enough areas, so I envision that they may do more like multiple choice without the choices so that you have a variety of things to do. But I don't know for sure, and we're not supposed to find out much more until the end of April. So check your email. I did give you a link to a webinar for your folks where they may be able to find out a little more, but it's not math specific, so it may not be that sort of information. All right, so on the axis provided, sketch a slope field for the given differential equation at the 12 points indicated. So here's our equation. When y is 1, these will be 0 because 1 minus 0 is 0. 0 times anything is 0. When x is 0, these will be 0 because 0 squared is 0 times anything is 0. So we really only have a few we have to calculate. 1, 0 will give us 1 times negative 1. Negative 1, 0 will give us 1 times negative 1. 1, 2 will give us 1 times 1. Negative 1, 2 will give us 1 times 1. And 1, 3 will give us 1 times 2. And negative 1, 3 will give us 1 times 2. So there's our slope field. Now, how do points typically work on a problem like this? Usually you get 1 point for all of the 0 slopes, which 1 point if all those are 0, and then 1 point for the other ones that are not 0 as long as they're all correct. So B, while the slope field in part A is drawn at only 12 points, it is defined at every point in the xy plane. Describe all the points in the xy plane that are positive. Well, this is going to go on forever, so it's not when x is equal to 0, but it will be everything out here and everything out here. So everything with a y greater than 1, because 1.1 would work, and x, I'm going to write an and first, and x not equal to 0. Then then it says find a particular solution. So that means separation of variables. So to do this, I'm going to get 1 over y minus 1 dy equals x squared dx, and we need to integrate. Fortunately, on the left side, the derivative of that denominator is 1, which means the antiderivative will just be ln of y minus 1. And you can check that. If you were to derive ln of y minus 1, you'd get 1 over y minus 1 times 1, so it is correct. Antiderivative of x squared is 1/3 x cubed plus c. So now I'm going to solve it. Let's change the form. E to the 1/3 x cubed plus c equals y minus 1. Or, again, it's added, so it's multiplied. This becomes c e to the 1/3 x cubed equals y. Oh, plus 1 equals y, sorry. Rewrite this and add this 1 at the same time. And it wants the particular solution at this point, 0, 3. So I'm going to plug my 0 in for x. E to the 0 is 1, so this just becomes c. And y is 3, so c ends up equaling 2, which means our particular solution is 2e to the 1/3 x cubed plus 1. Using this point here and plugging in our c value. So, if you have questions on this, please ask. Let me know if you have any trouble, and I will be available for questions. Let me know.